This is a tutorial on how to balance the equation you see on the screen. The goal of balancing equations is to ensure we are obeying the law of conservation of mass. And to obey the law of conservation of mass, we have to have the same number of atoms on the left side of the arrow as the right side of the arrow. The left side of the arrow is what we call reactants, and the right side of the arrow is what we call the products. Now, I'm going to show you a very visual way of how to balance equations. And the visual way is to stack the molecules on top of each other so that we can actually count out the atoms a little bit easier than if we're just multiplying the coefficients by any subscripts. So what we're going to do is we're going to start off by focusing on just one element at a time. I'm just going to go ahead and focus on carbon because it's the first element in line. And so since I see 3 carbons on the reactant side, I want to also have 3 carbons on the product side. But I'm not allowed to just put a little subscript of 3 there. I have to actually add the entire molecule so that, because carbon dioxide is the molecule present. So to do that, I'm going to go ahead and stack 1, 2, and 3 carbon dioxides on top of each other. Now I have 3 carbons on the reactant side and 3 carbons on the product side. You might notice that I actually added some oxygens along the way, and that's just part of the rules. We'll focus in on oxygen at the end because we actually see oxygen in 2 different products. So to reduce confusion, let's focus on oxygen at the very end. For hydrogen, I see 2 hydrogens on the reactant side. I see 8 hydrogens on the reactant side, and I need 8 hydrogens on the product side. And so far we see 2. So in order to have 8, I'm going to go ahead and add more water molecules. So now I have a total of 4 hydrogen. There's a total of 6 hydrogen, and now I have 8 hydrogen. So 3 carbons on the reactant side, 3 carbons on the product side. 8 hydrogens on the reactant side, 8 hydrogens on the product side. And so now I'm going to go ahead and count up all of the oxygens on the product side. There are 2, 4, 6, 7, 8, 9, 10 oxygens on the product side. I need 10 oxygens on the reactant side. So far I have 2, 4, 6, 8, and 10. It looks like my reaction is all balanced out, so I'm going to go ahead and add in some coefficients. The coefficients will be representing how many molecules are present in the reaction. Here I have 1 molecule of this, but usually we don't write in the 1 at all. It's mostly just, it's mostly understood, so we don't write it in. I have 1, 2, 3, 4, 5 molecules of oxygen, so there's my coefficient of 5. I have 3 carbon dioxides, 1, 2, 3, and 1, 2, 3, 4 water molecules. My coefficients are now 1, 5, 3, and 4.